I am Jennifer B. Zapata, grade 11 Gymnasiums. Welcome for today's video. We will derive into the fascinating world of logarithms and explore their fundamentals law. By the end of this video, you'll have a solid grasp of the understanding the laws of logarithm, the product law, quotient law, power law, inverse logarithm property, zero law, logarithm of a reciprocal, identity property of logarithm, inverse property of an exponent, and the change of base law. Okay, first up we have the product of law. This law states that the logarithms of a reciprocal is equal to the sum of the logarithms of the individual numbers being multiplied. So here is the formula of the product law. Log base b, quantity of x and y, equivalent to log base b, quantity of x plus log base b, quantity of y. And here is the example of the product law. Log base 2, quantity of 2 times 4, equivalent to equals to log base 2, quantity of 2 plus log base 2, quantity of 4. Okay, let's proceed to the quotient law. Their law tells that the logarithm of a quotient is equal to difference of the logarithm of the numerator and denominator. So the formula of quotient law is log base b, quantity of x over y, equals log base b, quantity of x minus log base b, quantity of y. So the example for this is log base 3, quantity of 2 over 4 equals log base 3, quantity of 2 minus log base 3, quantity of 4. Okay, now let's proceed to the power of law. This law states that the logarithm of a number raised to a power is equal to the exponent times of the logarithms of the base. So the formula of power law is log base b, quantity of x to the exponent of n equals n times log base b, quantity of x. The example for the power law is log base 3, quantity of 5 to the exponent of 2 equals 2 times log base 3 to the quantity of 5. So, okay, let's move on to the inverse logarithm. The inverse logarithm property is the key concept. It is essential since that the logarithm and exponential are inverse operation. So, the formula of inverse logarithm property is log base b, quantity of b to the exponent of x equals x. The example for this is log base 2, quantity of 2 to the exponent of x equals x. Okay, now let's move on to the zero law. Moving on to the zero law, which states that the logarithm of the any base is always 0. So, for example, for the formula of the zero law is log base b, quantity of 1 equals 0. So, here is the example of zero law. Log base 7, quantity of 1 equivalent to 0. So, let's move on to the logarithm of reciprocal. The logarithm of reciprocal, it tells us that the logarithm of the reciprocal of a number is equal to the negotiation of the logarithm at the original number. So the formula of logarithm of reciprocal is log base b quantity of 1 over x equals log base b quantity of x. So the example is log base 4 quantity of 1 over 3 equals log base 4 quantity of 3. So now let's move on to the identity property. The identity property of logarithm states that the logarithm of a number to its own base is always 1. So the formula of the logarithm, the identity property of logarithm is the log base b quantity of b equals 1. So here's the example. Log base 4 quantity of 4 is equivalent to 1. So next up, the inverse property of an exponent. The inverse property of an exponent, the inverse property of an exponent is a concept part of the power law. It says that if we take the logarithm of a base to a certain power, we get the exponent itself. So the formula of inverse is b to the exponent of log base b quantity of x equivalent to x. So the example for inverse is 10 the exponent of log base 10 quantity of 100 is equivalent to 100. So last one, the change of base law. The change of base law, which allows us to switch between different bases, we're working with logarithms. So the change of base law formula is log base b quantity of x equivalent to log base c quantity of x over log base c quantity of b. So the example for this is log base 2 quantity of 5 equals log base 3 quantity of 5 over log base 3 quantity of 3. Let's take 2. Okay. And there you have it, the fundamentals law of logarithms. I hope this video has been helpful and demonstrating this concept. If you have any question or there's a specific topic you'd like to us to cover in the future, please let us know in the comment section below. Bye and happy learning!